So represent f2 of t in terms of step signal. Represent f2 of t in terms of step signal. The very first step that you're going to do, is to identify the points where there is a sudden increase or decrease in the value of amplitudes. Where there is a sudden, not sudden increase in the value of amplitude or sudden decrease in the value of amplitude. So here you can see that the sudden increase in the value of amplitude, 0.1. Here there is a sudden increase in the value of amplitude from 2 to 5, 0.2. You can see at t is equal to 0, the amplitude is falling suddenly from 5 to minus 5, 0.3. At t is equal to 2, the amplitude is suddenly increasing from minus 5 to plus 1, 0.4. And at t is equal to 3, there is a sudden decrease in the value of amplitude, point number 5. So we can find 1, 2, 3, 4, 5. There are 5 points where there is a sudden increase or decrease in the value of amplitude, right? Sudden increase or decrease in the value of amplitude. Now, using the representations, I will try to represent, right? So here at t is equal to minus 2, there is a step. So I can write it as u of t plus 2. At t is equal to minus 2, there is a step. At t is equal to minus 1, there is a step. U of t plus 1. At t is equal to 0, there is a step. U of t. At t is equal to 2, there is a step. U of t minus 2. At t is equal to 3, there is a step. U of t minus 3. Correct? Now, this is the first step, to identify the points where there is a sudden change in amplitude. So I have indicated there are 5 steps in it. Now, I will be writing the coefficient, and I think this is where many of you are getting confused. Please look at the board over here. T is equal to minus 2, before it and after it. Before is the initial amplitude, after it is the final amplitude. You can see this value is 2 and this value is 0. So final amplitude minus initial amplitude. Final amplitude minus initial amplitude. So it is 2 minus 0, which is 2. 2 minus 0, which is 2. Next. At t is equal to minus 1, after, before. After crossing the step and before crossing the step. After crossing it is 5, before it is 2. So 5 minus 2, it is plus 3. And again at t is equal to 0, after, before. After step it is minus 5, before step it is plus 5. So final minus initial. So final is minus 5 minus initial. So minus 5 minus 5, it is minus 10. Okay. At t is equal to 2, after, before. So after it is 1, before it is minus 5. So final amplitude minus initial amplitude. Final amplitude is 1 minus initial amplitude, which is minus 5. Final amplitude, which is 1 minus initial amplitude, which is minus 5. So 1 plus 5, it is plus 6. And the last one, at t is equal to 3, final, initial. So final is 0, initial is 1. So final is 0 minus initial, which is 1. 0 minus 1, it is minus 1. So the expression for f2 of t in terms of the step functions is that 2 into u of t plus 2 plus 3 into u of t plus 1 minus 10 into u of t plus 6 into u of t minus 2 minus 1 into u of t minus 3. Okay. See, now we have to do the opposite. So from the expression which is from the equation which is given to us in terms of step, now we have to plot it. 3 into u of t plus 2 into u of t minus 1 minus 5 into u of t minus 4. So there is a step at t is equal to 0. There is a step at t is equal to 1. There is a step at t is equal to 4. So before t is equal to 0, there is no signal available. Before t is equal to 0, there is nothing which is available. To that nothing, now you are adding a step of 3 units. To that nothing, now you are adding a step of 3 units. It means that you are adding a step of 3 units. And you will go on with the same amplitude. You will go on with the same amplitude till you add anything to it. Till you add anything to it. For example, if this particular signal is not present, then it would have gone something like this. But here at t is equal to 1, you are adding an amplitude of plus 2 units. At t is equal to 1, you are adding an amplitude of plus 2 units. So when you add an amplitude of plus 2, what it becomes? When you add an amplitude of plus 2, already existing 3, now you are adding 2. Now you are adding a step of 2 units. If you add a step of 2 units, the resultant is going to become 5. The resultant is going to become 5. Okay? So we will go on till we are adding anything to it. Till we are adding anything to it. So we would have gone ahead if nothing was there after that. But what you are doing here, at t is equal to 4, you are adding an amplitude of minus 5. Or I can say, I am subtracting minus 5 from the already existing amplitude. From the already existing amplitude, I am subtracting 5. So the already existing amplitude is 5. If you subtract 5, it becomes 0. It becomes 0. So resultant will be something like this. It falls and it becomes 0. And this is how the graph is. Okay. Now you can do the opposite also. From here also we can get the same expression. And just as a homework, right? So take this as a homework. So this is the answer for the question. So students, so whatever we have learned in terms of step, we have to blindly apply in the case of ramp. But we have discussed sudden change in amplitude in the case of step. But now here we have to change in terms of slope. That is the only change we have. We have to see the sudden change in the value of slope over here. Whatever we have seen in the case of the step signals in terms of amplitudes, now we have to see it in terms of slopes. Right, so here the slope is 0. What is the slope of this line? Can you please tell me what is the slope of this line? Change in x, change in y. Change in x, change in y. What is slope? The slope is m is equal to dy by dx. So change in y is 4 units. The change in y is 4 units. Change in x is 2 units. Okay. So I'm just seeing the magnitude of it. Okay. I'm not going into the sign of it. I'm just seeing the magnitude of it. Here the change in magnitude is 4. Here the change in magnitude is 2. So 4 divided by 2 is 2. And how can I see the sign of it? If it is going up, it is going to be positive slope. If it is going down, it is a negative slope. And believe me, I'm approaching from left to right. I'm approaching it from left to right. Okay. So here, as I'm going from left, I can see I'm moving up. This is what we call as a positive slope. As I'm coming down, this we call as a negative slope, right? So if you have a road which is something like this, this is what we call as a positive slope. So when you have a positive slope, you gain amplitude. When you have a negative slope, you lose amplitude. As simple as that, right? So here, you can see the change in y is 4 units. The change in x is 2 units. So 4 by 2, it is 2. It is 2, and plus is because it's a positive slope. And similarly over here, change in y is 4, change in x is 2. So 4 by 2, it is 2 again, but it is coming down, therefore a minus 2. Therefore it is minus 2. And again, at t is equal to 2, after crossing it, the slope now becomes completely 0 because it's a horizontal line with 0 signal. There is no signal. So therefore it is going to be a 0. Therefore it is going to be a 0 slope. One is minus 2. One is minus 2. The other is 0. And the third one is plus 2. Minus 2, 0 and plus 2. We often forget about 0, but actually there is a slope change which happens at 0 also. So, because I have identified 3 points where there is a sudden change in slope, because you can see that the slope is suddenly varying from 0 to 2 at a single point. And here at t is equal to 0, the slope is suddenly changing from plus 2 to minus 2. And again, at t is equal to 0, the slope is again changing from minus 2 to 0. Okay? So, because I have identified the slope points, the ramp points, so now I am going to write it in terms of ramp. Whenever there is a change in slope at t is equal to minus 2, there is a sudden change in slope at t is equal to minus 2, so therefore I can write it as r of t plus 2. There is a sudden change in slope at t is equal to minus 2, I can write it as r of t plus 2. There is a sudden change in slope happening at t is equal to 0, I can write it as r of t. There is a sudden change in slope happening at t is equal to 2 plus 2, I can call it as r of t minus 2. I can call it as r of t minus 2. Now what is the coefficient? The coefficient, just like the way we have discussed, final amplitude minus initial amplitude, here it is final slope minus initial slope. Means before crossing this point is the initial slope, after crossing this point is the final slope. And please be attentive here, I am not looking at the amplitude, I am looking at the slope. I am not looking at the amplitude, I am looking at the slope. Can you please tell me that what is the slope at after crossing t equal to minus 2? After crossing t is equal to minus 2, what is the slope of it? After crossing t is equal to minus 2, the slope is going to be plus 2, which is the final slope. The initial slope is going to be 0. So 2 minus 0, 2 minus 0, it's going to be plus 2. 2 minus 0 is going to be plus 2. Here, whenever I wanted to see the magnitude of ramp, at t equal to 0, so t is equal to 0, after crossing that, before crossing that. So after crossing, the slope is minus 2, not the amplitude, the slope, right? So after crossing, the slope is minus 2, before crossing the slope is going to be plus 2, right? So final slope is minus 2 minus initial slope is plus 2. So totally it's going to become minus 2, it is minus 4. It's going to become minus 4 over here. And at t equal to 2, at t is equal to 2, after crossing this point and before crossing this point, after crossing it is 0, minus before crossing it is minus 2. So before crossing it is minus 2 and after crossing it is 0. So 0 minus minus 2, it's going to become plus 2. So the final result for us is f of t is equal to 2 times root of r of t plus 2 minus 4 r of t plus 2 into r of t minus 2. We are trying to represent the signals in terms of step and ramp signals, right? So we have covered the examples on how to represent a signal in terms of step and also how to represent a signal in terms of ramp. So now we are having 3 signals. Again here we can represent the signals in terms of steps and ramps. Okay, you are not forced to represent the signal in terms of both step and ramp. So you can use the step and ramp wherever it is required. Okay, so based upon the requirement, you can use the step and ramp. I'm sure you understand that ramp should be used whenever there is a sudden change in the value of slope at certain points. Whenever there is a sudden change in the value of slope at certain points, we use the concept of ramp, whereas step will be used whenever there is a sudden change in the value of amplitude. Now, first of all, we'll look at F2 of t. F2 of t. Looking at F2 of t, do you sense any particular point where there is a sudden increase or decrease in the value of amplitude? Do we sense any particular point where there is sudden increase or decrease in the value of amplitude? You can see it is linearly increasing, constant, linearly decreasing. So we don't see any particular point where there is a sudden increase or decrease in the value of amplitude. Correct? It means that step is out of picture. Step is completely out of picture. Now what we have is ramp, right? Ramp. Now you see that what is the slope of this particular line? What is the slope of this particular line? 2 units, 3 units. 2 units, 3 units. It's going to be 3 by 2. So 3 units of y and 2 units of x. 3 by 2 plus. And here it's 2 units, 3 units. So 3 units, 2 units. Again there is a 3 by 2 but with a minus. And in the middle, minus 2 to 2, the slope is going to be 0. Between the top minus 2 to 2, the slope is 0. R of t plus 4. Okay, because here we can see the change in slope from 0 to 3 by 2. At minus 2, 3 by 2 to 0. At t is equal to 0, there is nothing changing. At t is equal to 2, the slope is changing from 0 to minus 3 by 2. And at t is equal to 4, the slope is changing from minus 3 by 2 to 0. So the first one is r of t plus 4. The second one is r of t plus 2. The third one is r of t minus 2. And the last one is r of t minus 4. The slope changes from 0 to 3 by 2. The slope changes from 0 to 3 by 2. So 3 by 2 minus 0 is plus 3 by 2. 3 by 2 minus 0 is plus 3 by 2. Right? So t is equal to minus 4, final minus initial. At t is equal to minus 2. At t is equal to minus 2. Final minus initial. Final minus initial. Minus 3 by 2. At t is equal to 2. Final minus initial. Final minus initial. Minus 3 by 2 minus 0. Minus 3 by 2 minus 0, it's minus 3 by 2 only. At t is equal to 4. 0 minus 3 by 2, it's plus 3 by 2. I think in this example, we never saw any particular point where there is a infinity slope, isn't it? So, did you have any particular point where there is a slope of infinity? It's a horizontal line here. It's a horizontal line here, 0. We don't consider r of t because you don't see any change in the value of slope happening at t is equal to 0. We don't have any particular point, we don't have any change in slope happening at t is equal to 0. We will consider r of t only when there is a change in slope that is happening at t is equal to 0. T is equal to minus 2. At t is equal to minus 2, you can sense that the slope is changing from 3 by 2 to 0, isn't it? The slope is changing from 3 by 2 to 0. So what I'm saying is that after change, before change. So after change is what we consider as the final amplitude. Before change we consider as the initial amplitude. So final amplitude, I'm sorry, not amplitude, it is slope, right? So everywhere we are talking about slopes, right? So final slope minus initial slope. Final slope is 0 minus initial slope is 3 by 2. So 0 minus 3 by 2, it's going to be minus 3. I'm sorry, minus 3 by 2. It is minus 3 by 2. Next is F4 of t. F4 of t. Please tell me, do we see any particular point where there is a sudden increase or decrease in the value of amplitude? Do we have any particular instant where there is a sudden increase or decrease in the value of amplitude? At t is equal to 0, you can see a jump in the value of amplitude, isn't it? We can see a jump in the value of amplitude at t is equal to 0, isn't it? Yes or no? So it means that at t is equal to 0, at t is equal to 0, there is a sudden increase in the value of amplitude. It means that there is a step which is present in that signal. Now, apart from that, we don't see any particular point where there is a sudden increase or decrease in the value of amplitude. See, many students make a mistake understanding that if there is a line, it means that there is a ramp. If there is a line, there is a ramp. It is not the case. Ramp means that sudden change in the value of slope. That is the slope. I mean, that is a ramp here. Okay. And some students also think that when there is a constant, it means that there is a step. Okay. So these are the minor mistakes that the students do. Okay. If it is a constant, it is not the step. If there is a sudden change in the value of amplitude, there is a step. If there is a line which is something like this, it's not a ramp. But if there is a change in the value of slope which is happening at a single point, we call it as a ramp. And similarly, if it is something like this over here, there is a ramp. Right? So please understand the meaning of ramp and the step. So ramp indicates a sudden change in slope, and step indicates a sudden change in the value of amplitude. So we have identified one particular instant where the amplitude is going to change suddenly. Now let us look for more instants for the case of ramps, because there is no other instant for the step. First of all, let us write the slope values. Let us write the slope values at t is equal to 0. At t is equal to minus 2. Before that the slope is 0, and between minus 2 and 0 there is a line, and the slope of the line is 2 units here, 2 units here, so plus 1. 2 by 2, it's going to be 1. Here it's a horizontal line, so the slope is 0. Here it is 1 unit, here it is 4 units. So 4 by 1, it is 4. The line is coming down, so minus. And again there is a horizontal line, so 0. Okay, so now you can see at t is equal to minus 2, the slope changes suddenly from 0 to 1. At t is equal to 0, the slope changes suddenly from plus 1 to 0. The slope changes suddenly to plus 1 to 0. At t is equal to plus 1, the slope changes suddenly at a single point. The slope changes from 0 to minus 4. At t is equal to 2, the slope changes from minus 4 to the value of 0. The slope changes from minus 4 to the value of 0. Okay, so there are 4 instants of ramps and there is a 1 instant of step. See, the students make a mistake many a times at those points where there is both ramp as well as step. When there is both ramp as well as step, many students make a mistake. Okay, so I think we understood what is a step and what is a ramp, right? Where do we indicate the step and where do we indicate the ramp? Whenever there is a sudden increase or decrease in the value of amplitude, then we indicate with the of step. And whenever there is a sudden change in the value of slopes, something like this, something like this. So whenever there is a sudden change in the value of slopes, then we indicate with the term ramp. And it is very much possible that both step and ramp can exist at a single point. Both step and ramp can exist at a single point, and those are the points where many of us make the mistakes, right? So the first step is that to identify the points where there is a step and the ramp. Now once we have identified, we know how to represent it, isn't it? So how to represent it? At t is equal to -2, there is a ramp. At t is equal to 0, there is a ramp. At t is equal to 0, there is a step. At t is equal to 1, there is a ramp. At t is equal to 2, there is a ramp. At t is equal to 2, there is a ramp. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now first one. At t is equal to -2. Final slope minus initial slope. Final slope minus initial slope. 1 minus 0, it is 1. At t is equal to -2. Final slope minus initial slope. At t is equal to 0. First we are having a ramp. So whenever we are looking at, whenever we are talking about a ramp, we should only look at the slopes, not the amplitudes. Whenever we are having a ramp, we should only look at the slopes, not the amplitudes. So now at t is equal to 0, after that, before that. So after that there is a slope of 0, before that there is a slope of there is a slope of +1. Okay, so 0 minus +1, it is -1. Okay, and there is a step as well. So whenever we are talking about a step, we will not look at the slopes, we will only look at the amplitudes. So you can see, after crossing the slope, after crossing t is equal to 0, the amplitude is 4, before crossing it is 2. After crossing it is 4, before crossing it is 2. So 4 is the final amplitude, 2 is the initial amplitude. 4 minus 2, it is +2. 4 minus 2, which is +2. At t is equal to 1. At t is equal to 1, after, before. We are talking about the slopes once again, because we are only having r's after that. So when we are talking about the slopes, after, before. After it is -4, before it is 0. After it is -4, before it is 0. So final amplitude, final slope is -4 and initial slope is 0. So -4 minus 0, it is -4. -4 minus 0, it is -4. And the last one. At t is equal to 2, after is 0, before it is -4. After it is 0, before it is -4. So now the last one, f4 of t. The very first question is that, do we have any instant where there is a sudden increase or decrease in the value of amplitude? Do we have any particular instant where there is a sudden increase or decrease in the value of amplitude? Right. So now at t is equal to 4, and at t is equal to 4, there is a sudden decrease in the value of amplitude. You can see sudden fall in the value of amplitude. So yes, there is a step which is present in the signal. Yes, very good. Next is we are going to look at the slopes. Next we are going to look at the slopes. At t is equal to 0, at t is equal to 4. Let us see, before t is equal to 0, what is the slope which is present? Before t is equal to 2, what is the slope which is present? Before t is equal to 2, there is a slope of 0, because it's a horizontal line. Now between t is equal to 2 and t is equal to 4, what is the slope? Between t is equal to 0 and t is equal to 4, what is the slope? You can see that there is an increase in amplitude. The amplitude increases by 5 units. In this region, the amplitude increases by 5 units. And the coverage of x is going to be 2 units. So therefore, we can say 5 by 2. And because it is going up, it is plus 5 by 2. Because it is going up, it is plus 5 by 2, and after that you can see again the value of slope is going to be 0. After that again the value of slope is going to be equal to the drop 0, right? So now I can clearly see the ramp points. So at t is equal to 2, at t is equal to 2 I can see a sudden change in the value of slope from 0 to 5 by 2. At t is equal to 4, again I see the sudden fall in the value of slope. Sudden fall in the value of slope, right? So at t is equal to 4, we are having two things. One is ramp and the other is step. So once we have identified the points where there is a step and ramp, now we are going to write in the form of an equation. So r of t minus 2, next r of t minus 4, u of t minus 4. R of t minus 2, r of t minus 4 and u of t minus 4. At t is equal to 2 first of all. At t is equal to 2, after, before. After the slope is 5 by 2, before it is 0. So 5 by 2 minus 0 is 5 by 2. 5 by 2 minus 0 is 5 by 2. At t is equal to 4, after, before. After it is 0, before it is 5 by 2. So 0 minus 5 by 2, it is minus 5 by 2. Now we are talking about the amplitude. So whenever you see u, step, we will be talking about amplitude. Whenever we have r, we will be talking about slopes. So this is where we should not get confused, right? So whenever we are talking about u, final amplitude which is 0 and initial amplitude which is 5. Final, initial. So final amplitude is 0, initial amplitude is 5. So 0 minus 5, it is minus 5. 0 minus 5, it is going to be minus 5. So this is what we call as f4 of t. So let us not be so concerned about the options over here. So whatever way in which we started solving the problem of this type, let us do the same thing. So the very first thing is that we will look at the points where there is a sudden change in the value of amplitude. We look at the points where there is a sudden change in the value of amplitudes. Yes, please tell me the point where there is a sudden change in the value of amplitudes. Sudden change in the value of amplitudes. What are the points? Sudden change in the value of amplitudes. You can see at t is equal to 0. At t is equal to 0, you can see suddenly the amplitude increases from 0 to 1. At t is equal to capital T, at t is equal to capital T, amplitude falls down suddenly. Do we have any sudden change in the value of amplitude at t is equal to 0? T is equal to 2 capital T. At t is equal to 2t, do we have any sudden change in the value of amplitude? See, constant line doesn't mean that there is a step. That is what I am trying to tell you, that constant line doesn't mean there is a step. If there is a sudden change in the value of amplitudes, then only we will have a step. So now we have understood what are the points where we are having sudden change in the value of amplitudes. We have denoted it. Next thing is that we have to see the slopes. So for changing the for seeing the change in the value of slopes, first of all we have to indicate the slopes. Right? Here it is a horizontal line, so 0. Here also it is a horizontal line, so again 0. Here it's a line whose amplitude value coverage is 1. Time value coverage is t. So 1 by t. Amplitude coverage is 1 and time coverage is t. And again over here it is 0. Okay. Now let us see the points where there is a sudden change in the value of slope. Okay, at t is equal to 0, 0, 0, no problem. At t is equal to capital T, 0, 1 by t. At t is equal to capital T, 0, 1 by t. So therefore, definitely the slope is changing from 0 to 1 by t. Right? At t is equal to 2t, at t is equal to 2t, the slope is changing from 1 by t to the value of 0. 1 by t to the value of 0. So I think we have identified all the points where there is a sudden change in amplitude first and then about slope. Now let us try to write it in the form of an equation. Right? So starting with t is equal to 0, left to right. Starting from t equal to 0, so we are having a step here. So u of t. Here also we are having a step. U of t minus capital T. There is a ramp also. R of t minus capital T. R of t minus 2 capital T. At t is equal to 0. At t is equal to 0, amplitude change, final amplitude, initial amplitude. Final amplitude is 1, initial amplitude is 0. Final minus initial is 1. At t is equal to capital T, final amplitude is 0, initial amplitude is 1. Final amplitude is 0, initial amplitude is 1. 0 minus 1, it is minus 1. 0 minus 1, it is minus 1. Next, at t is equal to capital T, now we are going to look at the slopes. Now we are going to look at the slopes. At t is equal to capital T, final slope is 1 by t, initial slope is 0. Final slope is 1 by t, initial slope is 0. So 1 by t minus 0, it is 1 by t only. 1 by t minus 0, it is 1 by t only. At t is equal to 2t, at t is equal to 2t, final slope is 0, initial slope is 1 by t. Final slope is 0, initial slope is 1 by t. So 0 minus 1 by t, 0 minus 1 by t, it is minus 1 by t. Okay, so this is the signal which is given over here. But we don't see any ramp functions. We don't see any ramp functions in the options. But nothing to worry, because we already know the relation between ramp and step, something like this, right? This is something we have seen in the last class, right? Of course, we have a representation in terms of integration differentiation, but apart from that, we also have a representation that R of t is equal to t into u of t. Do we know this? Yes or no? Did we indicate it as important? Okay, so this is the place where, right, so you might not be given directly in terms of R, but R is nothing but t into u of t. Okay, so that is where we have to know this relation, right? So if R of t is t into u of t, I can write R of t minus capital T. I can write R of t minus capital T. Just replace t with of t minus capital T. Replace t with of t minus capital T. Then what it will become? T minus capital T into u of t minus capital T. Similarly, R of t minus 2 capital T will be what? Just replace t with of t minus 2t. Just replace t with of t minus 2t. That's it. Now you can substitute. Let us substitute here. So it is u of t minus u of t minus capital T. Next we have t minus capital T by t, u of t minus capital T, and the last one is minus right. So what is the right answer? The only correct answer we have in the option is A. So this relation is the key. Without this relation, it's very difficult to answer this question.